Okay, section 4.2, ratios. So just continuing this discussion of fractions in the real world. Okay, so first, what is a ratio? I think I've kind of already defined it in the last section, but I'll just say it again here. A ratio is a fraction of two quantities that are comparing two units that are of the same category. So I'll just say is a fraction used to compare two measured quantities with, let's say, whose units are in the same category. Alright. So in the notes I say whose units are of the same type. Yeah, that's pretty much. I think I like to say this better now, though. They're in the same category. Same type, kind of to me, might imply that they're exactly the same, but that's not necessarily the case. It's just that a ratio is not comparing necessarily two units that are exactly the same. They're just kind of in the same category. We can denote a ratio three different ways. We can denote it as a fraction. I'll just say a over b. So this would be some number with some unit attached, and then some number with some unit attached. Or with a colon between the numbers and the units. Or in words, a to b. So there's three different ways to denote a ratio there. Alright, so I'm just following through the notes here. Example 1 says there are 12 blue marbles, 8 red marbles. Let's see, 12 red. Oh, I already messed it up. 12 blue, 8 red, and 5 green marbles. One second. That's a bit better. Okay, 12 blue marbles, 8 red, and 5 green. Part A is telling us to, well, all of the parts really are telling us to write some ratio of some color to some other number. And we want all the ratios to be simplified, and we want to write the answer in three different ways. So the first one is write the ratio of blue to red marbles. So initially, I'm going to write it as a fraction, and then I'm going to simplify it. Once I have the simplified fraction, I will write it in the other formats. So blue to red, right? So blue to red, so the order matters here, should be blue over red. So there's my fraction, there's my ratio, but it's not simplified. So let me go ahead and simplify it. And what does simplify mean? It just means pull out common factors in the fraction, right? So I can pull a 4 out of both of these, leaving me with a 3 over 2, and of course still need those units, so 3 blue marbles to 2 red marbles. Okay, so there's part 1 of part A, right? They want the answer three different ways, meaning using all three of these notations. So I've got the fraction representation of the ratio, that's that one, and then I've got the colon representation, so 3 blue marbles, colon 2 red marbles. And then I've got the kind with the word 2 in the middle. Okay. So that's just 3 different ways to notate the ratio of blue marbles to red marbles in this situation. Alright, so for the next ones, we'll just pick one notation instead of doing all 3. So part B says, what is the simplified ratio of red to blue marbles? Okay, so the opposite, right? So red to blue is going to be 8 red colon 12 blue. But remember, it needs to be simplified. So, I left out the word marbles. We should be specific about the units. I'll try to stick to that. I'll try not to be lazy and leave off words. Okay, so I need to simplify this. Again, I can pull a 4 out. So it's going to be 2 red marbles. Now, if you find it tricky to look at this and understand how the simplifying is going to work when it's in this format of the colon or with the word 2, because it's all horizontal, if it's better for you to see the numbers stacked on top of each other, like it would be for the fraction representation with 8 over 12, for the purpose of simplifying, then that's fine. Do that if you need to. Just make sure whatever the question is asking, you put your answer in whatever format, if you're working in Hawks, whatever format you need for the problem. Make sure you have that written down at the end. Okay, C is blue to total. Okay, so that's interesting. We want the ratio of blue marbles to total marbles. So there are 12 blue marbles. I'll write it in fraction format. To how many total marbles? Well, there are 12 blue, 8 red, that's 20, and 5 green, so 25 total. 25 total. Okay, and that's it. Cannot be simplified. It cannot be simplified because the only factors of 25, besides 1 and 25, are 5s, right? 5 times 5 is 25. And 5 is not a factor of 12, so that's it. Cannot be simplified. Part D says, what is the ratio of total to green marbles? So total is already 25, I have that written down, and green is 5. So I want 25 total marbles. I'm going to write it in the word form this time with the word 2 in the middle. 5 green marbles. And I'm seeing that this ratio can be simplified because 5 goes into 25. So again, if this is weird to you, simplifying this way, just write the numbers as a fraction on the side real quick. Maybe don't even worry about the units. Make sure you get the order right? So this number over this number. And then just simplify. Okay, so that's 5 over 1, which if we were just working with numbers and not these units, you would just say is 5, right? 5 over 1 is just 5. But you don't want to do that last step here because we still have units attached here, so you don't want green marbles to completely disappear. So what it would look like as a ratio is, at least in this format, is 5 total marbles to 1. So you still want that 1 there to be attached to the green marbles unit. If you wrote that as a fraction, it would be 5 total marbles to 1 green marble. Alright, example 2 from the notes says, if 48 of the 84 people who swim at the YMCA are adults, okay. So that's giving me 2 numbers here, each with units attached. 48 of the 84 people who swim at the YMCA are adults. That means that there are 48 adults, and there are 84 total. They're giving me two numbers with two different units attached there. They didn't specifically say the word total, but they say, of the people who swim at the YMCA, that implies like total, or at least for like a day or something like that. What is the ratio of children to adults who swim at the YMCA? So we want children, we want some number of children per some number of adults. So we want some number per some number of adults. And then it says, write the ratio in lowest terms as a fraction or with a colon. So that just means make sure your ratio is simplified. Okay, so we've got to make some assumptions here. So we don't know what the number of children is, right? We know that the number of adults is going to be 48, so there are 48 adults. But how do we know how many children there are? Well, we have to assume that of the 84 people that are there is only two categories. There's only going to be adults and children. So we're assuming like there's a strict cutoff. There's no other age group like, babies or teenagers or seniors. Everyone's either an adult or a child. And with that being known, that means that if we take the difference of these two, we'll have the number of children. So if there are 84 total and there are 48 adults, then that must mean that there are 36 children. Okay, there are 36 children. And remember that the assumption we made there was that there was only two categories. If there was some third category that we didn't know about, like if there was adult, children, and then, children were like ages 0 to 12, and then there's adults, which are ages 18 and up, and then there was like another category from 13 to 17, which are teenagers. If we didn't know that number, then we couldn't do this, right? If there was a third category. But there's not. It's implied there's only two categories. Now we've got our ratio. They ask to write it as a fraction or with a colon. So we're good. We wrote it as a fraction, but we do need to simplify it. And we know that we can pull out a common factor of 12 from both of these. So for every 3 children, there are 4 adults. It's the same as saying for every 36 children, there are 48 adults. The ratios here are the same. Okay. And if you don't recall, I'll very quickly, go over how I got 3/4 out of 36 over 12. 36 over 48. Just real quickly with the numbers here. I know that 36 can be written as 3 times 12. I know that 48 can be written as 4 times 12. So you got to know your factors. If you want to be able to simplify fractions, you got to know your factors. Then from here, technically what's going on, these are the details here, is I can pull that apart, pull that multiplication of fractions apart, but 12 over 12 is just 1, so 3/4 times 1 is just 3/4. So that's kind of let's be honest, none of us really do this part, right? We just say, okay, the 12s cancel and I got 3/4, right? But this is the details. This is what's actually happening. You're pulling off that 12 over 12, which turns into a 1, which is the multiplicative identity, meaning that when you multiply it by any number, it preserves that number's identity, meaning it doesn't change it. Okay. Okay, example 3. I was looking through the homework a minute ago and I saw this problem in there. Well, a similar problem. It says the ratio of 1.5 to 27 is the same as the ratio of 4.5 to what? Some number. Okay, So looking at this problem here, the ratio of 1.5 to 27 is the same as the ratio of 4.5 to some other number. And this problem's written in the notes, so I'm going to take this to the side. Alright, so let's say example 3 here again. Alright, we got a ratio of 1.5 to 2.7. Since we're looking to do math with this now, like there's no units attached necessarily, I'm going to write them as a fraction. They're writing them in the 2 format with the word 2 between the numbers, but I'm writing them in fraction format because we're all just more comfortable with that, right? And it's the same as, which means equals, the ratio of 4.5 to some unknown. There we go. That's how you set that problem up. It's a proportion. They're describing a proportion in words. You just got to figure out where the numbers go. Okay, and then remember to solve a proportion, we're going to multiply by both of these denominators at the same time, which you may know is cross multiplying. That's going to give us 1.5x is equal to whatever 27 times 4.5 is. Let's see. If I wanted to be lazy, I could try and pull it apart. That's 3 times 9. That's 5 times 9, so it's the same as 15 times 81 times 10 to the negative first, which is not much easier than just doing this, so I'll just do this. Alright, 5 times 2, and that's 10, and and then the decimal, so that shouldn't be there. 121.5. Does that feel wrong? It kind of does. I have a calculator right next to me, I'm just refusing to use it for some reason. And, oh, yeah. Okay, I got the same thing. Okay, so that's right, 121.5. And now we want to solve for x, so we're going to divide by 1.5 on both sides. And I'll choose to do it without a calculator again, just so you can see it if you'd like, or you can just cover your eyes if you don't want to see the decimal arithmetic. This is the same as doing 15 goes into 1,215. Scooting the decimal point out on each of these numbers. That's legitimate. That's the same as multiplying by 10 in the top and bottom, right? Which is, it's legitimate as long as you do it in the top and bottom. Now I don't have to deal with the decimal point. How many times does 15 go into 121? Let's see, maybe 8 times, right? 8, yep, that would be, oh wait, that's what this is. Okay, so x is 81. X is 81. Okay. If you just got like super confused about why I did this, well, I don't want to go off on too much of a tangent, but I know that 27 is the same as 3 times 9. And I know that 45, which I'm just treating this as 45 instead of 4.5, that's the same as 5 times 9. So if I what I was trying to do is mix up these numbers to see if there was a better way to multiply them to figure out what the product would be. So I said, oh, well, 9 times 9 is 81, and 3 times 5 is 15. So that's why I was thinking about that. Maybe this is an easier product than 27 times 45. It didn't really turn out to be that much. You can't really do that in my head either. But it just so happens that that ended up being what I needed in the division over here. Now, without worrying about any of this, you could just do it all with a calculator, right? You could do 27 times 4.5, get that, and then you could do 121.5 divided by 1.5 to get 81. Now, also note that if you had noticed how 1.5 was scaled up to 4.5, then you would easily be able to get to 81 without even doing these steps. It's okay if you didn't, right? But think about, what do you multiply 1.5 by to get to 4.5? It would be a 3, right? A 3. And what is 27 times 3? It's 81. But remember from our proportions discussion that it doesn't matter what that scaled up number is. It doesn't matter what it's being scaled up by. Yeah, sorry, that's what I meant to say. It doesn't matter what it's being scaled up by, because this process here always works, and this process does not care what the number was scaled up by. It just gets you to the answer of what that number should be. It completely bypasses the times 3, right? Alright, let's go to example 4. Example 4 says, an election is over and a new student body president has been elected. I can't read my problem, let me zoom out. The new president received 4 votes for every vote received by his opponent. The new president received 2,432 votes. How many votes did his opponent receive? Okay. Let's get that ratio down. It says blah 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 blah. New president. So we have to notate one of the units is going to be votes for new president. He received 4 votes for every 1 vote received by his opponent. So there were 4 votes for who? For the guy who won, or girl. Does it say? Oh yeah, it does say it doesn't say who his opponent is, but anyways, 4 votes for new president. And it says for every, so that's another way of saying like 2 or setting up a ratio. For every 1 vote received by his opponent. So it says for every vote received by his opponent, we understand that that means 1 vote. And I'll just call the opponent. So I've taken that sentence and pulled a ratio out. So I had to make some assumptions here, or well, not really assumptions, but I had to make some observations here. The statement for every is like the word to in the setup of a ratio. Okay, it's just another way of saying that. So 4 votes for the new president for every 1 vote for the opponent. I also had to, I feel like this is more obvious, but in the sentence they say 4 votes for every vote received by his opponent. So they don't specifically say 1 vote for the opponent, but they say for every vote. But if they leave out the number, then you know it's a 1, right? It's a 1. Okay. So the new president actually received 2,432 votes for the new president, and we want to know how many did his opponent receive. But they already gave us the ratio that it should be equivalent to, right? 4 to 1. And notice I'm making sure that I'm going to line up my units. The votes for new president should be on top. So it's 4 votes for new president for every 1 vote for opponent. So I'm taking the ratio they gave me in the setup of the problem and setting it equal to the ratio that they're asking about at the end of the problem, because it should be equal, right? It should be. If the president got 4 votes for every 1 for his opponent, then in the end, if he got this many total, then we should be able to find the total back here just by dividing by 4. If you have the intuition to see through this problem, you'll see like, well, if he got 4 times as many, then this is 4 times as many as that, so we just need to divide by 4. But if you trust the process of the proportion here, you can just follow that through, and it will carry you to the division by 4, because you will have 4x. 4x is equal to 2432. And notice I'm leaving the units off here, right? and then in the end you're going to end up dividing by 4. So you can either let your intuition guide you through this problem all the way to the solution, or you can just set up the proportion, and the proportion will carry you right through without any intuition, right? All you got to know for the proportion is how to set it up and how to divide, right? How to use a calculator. And that's going to be 24, so 4 goes into 24 6 times, so that would be 600, and then the extra 32 is an 8, so 608. And then at the end is where we would tack on the unit votes for opponent. Okay, so that's all the problems I have for this ratio. It's basically just problems I pulled from like the homework. What I'm going to do now though is I'm going to pause the video for myself, pause recording, and I'm going to go look through 4.2 homework because someone asked specifically about it. I'm going to see if there are any problems of any type that I missed here, and if there are, I will be back to do those. But you won't have to wait because I'm just going to pause recording. Okay, I'm back. I found one that's a little different. It takes a little bit more critical thinking. It is, I'm going to write down the entire problem, in fact. Okay, here's the problem. It was recently estimated that domestic vehicles outnumber foreign vehicles by about 9 to 7. If there are 6,032 vehicles in a county, how many of them are domestic? So this is a little different because they're giving us a ratio of domestic vehicles to foreign vehicles, and then a total, right? A total. And we want to know how many vehicles are just in one of those categories. So, first let's write down this ratio. We have it as domestic vehicles outnumber foreign vehicles by about 9 to 7. So we have 9 domestic vehicles, so Fords and Chevys and other such cars, and then the 7 foreign vehicles like Saabs. Well, that's a weird example. Saab is not a good example. Like Toyotas and stuff. Okay. Is Toyota foreign though? Because they're made here? Or is it just where? Yeah, whatever. It doesn't matter. Okay. We want to know how many are domestic, and we have this total here. We have this total. We don't have like the total domestic or total, so we can't directly set up a proportion yet. So what we've got to do is we got to be a little sneaky here, and we got to come up with a new ratio that does involve total vehicles. Now obviously this involves total, but we need this ratio to somehow give us something to do with total vehicles. So how could we create a new ratio that involves both domestic cars? So we'd like to keep the top as domestic because we know that needs to be involved. And then down here we want total vehicles, because this is the ratio that we want to be equal to. We want some X number of domestic vehicles per the total of 6,032 total vehicles. So what is this number? Based off of this ratio, if there are 9 domestic vehicles for every 7 foreign vehicles, then aren't there also 9 domestic vehicles for every 16 total vehicles, right? 16. Because 9 plus 7 is 16, right? So if I'm looking at like a rectangle of all the vehicles, there are 9 domestic over here and 7 over here, then what's the total in this ratio? It's altogether it's 16, right? So I've forced a new ratio out of this just by adding these two together and making it 9 domestic per 16 total. And now I'm ready. Now I've got it set up. It's just a matter of solving the ratio. I'm not going to do this multiplication by hand. I'm going to say in the calculator 9 times... Well, actually, it wouldn't be that hard. That would be 50... No, it's fine. I'll do it with a calculator. Alright, 54,288, and then divided by 16. $3,393. Oh, with the unit. The unit is domestic vehicles. Whoops. Sometimes they'll I think actually most of the problems, yeah, they just leave you a box for the number and they write the unit next to it. Okay. Oh, let me look through the rest of them real quick. There's only a couple. No, the rest of them look okay. Pretty much all proportional stuff. Okay, that is it.